In 2012, Russian archaeologists working in a remote Siberian cave made what seemed like the most mundane discovery imaginable. Among thousands of bone fragments scattered across the cave floor, they catalogued one tiny chip, smaller than a coin, weighing barely more than a paperclip. Fragment DC-1227, they labelled it. Just another entry in an endless catalogue of unidentifiable remains. They had no idea they had just unearthed evidence of the most impossible story in human history. For 3 years, this fragment sat forgotten in storage. But when Dr. Vivian Sloan finally held it in her sterile laboratory at the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, she was about to unlock secrets that would force scientists to rewrite every textbook on human history. The results would be so shocking that many researchers would refuse to believe them. What was hidden in this unremarkable piece of bone that could cause such an uproar? The first clue came when researchers applied a revolutionary new technique to distinguish human bones from animal remains among their collection. DC-1227 stood out immediately. Its protein signature clearly belonged to a human. But which human? And from when? This was no ordinary ancient human. When the DNA results came back, something was terribly wrong with what they found. The mitochondrial DNA, those genetic instructions passed down from mother to child in an unbroken chain stretching back hundreds of thousands of years, clearly belonged to a Neanderthal. The signature was unmistakable. Every geneticist who saw it agreed. This was definitely Neanderthal. But then they analysed the nuclear DNA, which comes from both parents. Half of it didn't match any Neanderthal genome on record. Instead, it belonged to something else entirely, something that, according to everything scientists knew about human history, couldn't possibly exist in the same individual. It belonged to a Denisovan. But how could one person carry DNA from both Neanderthals and Denisovans? These were supposed to be separate species, distinct branches on the human family tree that had split apart hundreds of thousands of years ago. Finding their DNA mixed together in a single individual was like discovering a creature that was half lion, half tiger, living wild in the African savannah. It should have been impossible. Yet there it was, written in the genetic code of a 13-year-old girl who had died 90,000 years ago. But who exactly were these Neanderthals and Denisovans? And why was their genetic mixing so shocking to scientists? The Neanderthals were no strangers to mystery themselves. Discovered in 1856 in Germany's Neander Valley, they had haunted human imagination for over a century. Were they our ancestors or our enemies? Gentle cousins or brutal competitors? The more scientists learned about them, the more complex the picture became. These weren't the shambling brutes of popular imagination. Neanderthals had brains as large as modern humans, sometimes larger. They created the world's first cave art, painting handprints and geometric patterns on limestone walls 65,000 years ago. They crafted sophisticated tools, made jewelry from eagle talons and bear teeth, and buried their dead with flowers and offerings that suggested complex spiritual beliefs. They were master survivors who had thrived across Europe and Western Asia for over 300,000 years, weathering multiple ice ages that would have wiped out less adapted populations. Their robust skeletons could withstand forces that would shatter modern human bones. Their barrel chests and powerful limbs were perfectly designed for the brutal realities of Ice Age survival. Were they peaceful neighbours to other human groups, or fierce competitors who eliminated rivals without mercy? And then there were the Denisovans, perhaps the most mysterious human species ever discovered. Until 2010, no one even knew they existed. They were revealed not through dramatic fossil discoveries, but through painstaking genetic analysis of what seemed like insignificant bone scraps from a single cave in Siberia. A finger bone no bigger than a pebble. A few teeth. A skull fragment. That was literally all the physical evidence that existed for an entire human species. But their DNA told an extraordinary tale. The Denisovans had split from Neanderthals nearly 500,000 years ago and had spread across vast stretches of Asia, from the frozen mountains of Siberia to the tropical highlands of Southeast Asia. They had evolved remarkable adaptations, including genetic variants that allowed them to thrive at altitudes where other humans would suffocate. Most mysteriously, their genetic signature suggested they had interbred not just with Neanderthals, but with at least one other completely unknown human species, ghost humans whose fossils had never been found but whose DNA lived on in Denisovan genomes. Who were these phantom people? When did they live? How many different human species were actually sharing the planet during our prehistoric past? But perhaps the most unsettling question was this. If Neanderthals and Denisovans were both intelligent, sophisticated human species with their own territories and technologies, what happened when they encountered each other? For decades, scientists had assumed that different human species lived largely separate lives. Neanderthals in the west and Denisovans in the east. Occasionally their ranges might overlap at the edges, but meaningful contact would have been rare. Denny's existence shattered that comfortable assumption. Her perfectly balanced 50-50 genetic heritage proved that her parents hadn't just met, they had formed a relationship intimate enough to produce offspring. But was this a love story or something darker? The cave where Denny lived had seen human occupation for over 300,000 years. Different species had taken shelter there at different times, sometimes overlapping in ways that made archaeologists wonder, were they sharing the space peacefully, or fighting for control of this valuable resource? Evidence from the cave painted a complex picture. Neanderthal tools and Denisovan artifacts were found in the same layers, suggesting they had lived there simultaneously. But which group had arrived first? Who controlled the cave? And what happened when strangers from thousands of miles away showed up demanding shelter? The geographic evidence was particularly puzzling. Denny's Neanderthal mother carried genetic markers, showing she was more closely related to Neanderthals who lived in Croatia than to any local Siberian populations. This meant her people had somehow travelled over 4,000 miles across hostile terrain to reach Denisova Cave. But why? What could have driven a band of Neanderthals to abandon familiar European hunting grounds and undertake such a perilous journey? Climate data from 90,000 years ago revealed dramatic environmental upheavals across Eurasia. Ice sheets were advancing and retreating. Traditional hunting grounds were becoming uninhabitable. Animal populations were migrating in unpredictable patterns. Entire human communities were being forced to move or face extinction. Perhaps Denny's mother's people were refugees, driven from their ancestral lands by climate change and desperately seeking new territory. They might have arrived at Denisova Cave weakened by months of travel, vulnerable and in need of shelter. Or maybe they were conquerors, following migrating herds of mammoth and rhinoceros into Denisovan territory, prepared to fight for the resources they needed to survive. The Denisovans who controlled the cave had their own advantages. They knew the local terrain intimately. They understood the seasonal patterns of plants and animals. They had established hunting territories and food storage systems that could support them through the brutal Siberian winters. But the arriving Neanderthals brought something valuable too: knowledge of distant lands, new hunting techniques, and technological innovations developed during their epic journey across Eurasia. So when these two groups encountered each other for the first time, what actually happened? The first contact between these two groups of ancient humans would have been one of the most significant moments in human history, yet we can only imagine how it unfolded. One can only imagine a band of exhausted Neanderthal travelers approaching Denisova Cave after months of difficult travel. They would have seen the smoke from Denisovan fires long before they reached the cave entrance. They would have known the site was occupied. The critical question is, did they approach as supplicants seeking shelter, or as competitors prepared to take what they needed by force? The Denisovans watching from the cave would have faced their own difficult calculations. These strangers clearly belonged to a different human group. Their physical features, clothing styles, and tool technologies would have marked them as foreigners. But were they potential allies or mortal enemies? Both groups would have been armed. Neanderthals were skilled hunters who had perfected techniques for killing massive Ice Age predators. They carried carefully crafted spears and knew how to coordinate group attacks against dangerous prey. The Denisovans had their own sophisticated weapons and the defensive advantage of familiar territory. A single miscalculation, a moment of fear or aggression, could have turned this first meeting into a conflict that eliminated one group entirely. Instead, something remarkable happened. Somehow, these two groups of humans, separated by hundreds of thousands of years of evolution, found a way to coexist peacefully enough that intimate relationships could develop between them. But how? What bridging mechanisms allowed such radically different peoples to overcome their mutual suspicion and fear? Perhaps it began with trade. The Neanderthal travelers might have carried precious materials from distant lands, high-quality stone for tool-making, shells for jewelry, or rare pigments for body decoration. The Denisovans could have offered local resources in exchange: food, shelter, knowledge of the region's geography and wildlife. Or maybe the initial contact was forced by practical necessity. The cave was one of the few reliable shelters in a harsh landscape. During severe weather, both groups might have been forced to take refuge in the same space, creating opportunities for interaction despite their mutual wariness. There's even a possibility that one group dominated the other through superior numbers or technology. Perhaps the Denisovans allowed the Neanderthal band to stay only as subordinate members of their community, or maybe the arriving Neanderthals had advantages that allowed them to claim territory within the cave system. But whatever the initial power dynamics, the relationship eventually evolved into something that allowed for intimate personal bonds between individuals from the two groups. The question is, was the union between Denny's parents a matter of mutual attraction and choice, or was it the result of coercion, capture, or arranged marriage for political purposes? The relationship between Denny's parents represents one of the most fascinating mysteries in human history. Was it love that transcended species boundaries, or something more calculating? Denny's father was a Denisovan male who had grown up in the familiar chambers of Denisova Cave. His people had called this place home for thousands of years, developing sophisticated technologies and cultural practices adapted to the harsh Siberian environment. He would have been an expert in high-altitude survival, capable of functioning efficiently in conditions that would challenge modern humans. Recent archaeological discoveries at the cave have revealed remarkable evidence of Denisovan sophistication. Among the most extraordinary finds was a bone needle dated to 50,000 years ago, the oldest known needle in the world. This tiny artifact, crafted with incredible precision, demonstrated that Denisovans had mastered the art of creating fitted clothing essential for Arctic survival. The needle was a marvel of ancient engineering, its eye carefully drilled using techniques that required both patience and skill. The creation of such implements would have required not just physical dexterity, but the conceptual understanding necessary to envision how these tools could be used to create life-saving garments. This was the technological tradition that Denny's father represented, a lineage of innovators who had survived in one of Earth's most challenging environments through ingenuity and adaptation. But what was he like as an individual? Was he a leader in his community, or a young man still proving himself? Was he curious about the strangers who had arrived at his cave, or suspicious of their intentions? As mentioned earlier, Denny's mother represented an entirely different human tradition. Her people were master craftsmen who could transform raw animal hides into supple leather using techniques passed down through countless generations. They understood the seasonal patterns of Ice Age megafauna and could track massive herds across trackless steppes. They had developed complex social structures that allowed them to coordinate group hunts against dangerous prey like woolly mammoths and cave bears. Denny's mother had survived this epic journey, which suggests she was tough, resourceful, and adaptable. She would have possessed specialized knowledge about distant lands, alternative survival strategies, and technological innovations developed during months of travel through unfamiliar environments. When these two individuals, the Denisovan cave dweller and the Neanderthal traveler, first encountered each other, what was their initial reaction? Perhaps it began with mutual professional respect. Both were skilled survivors who recognized expertise when they saw it. He might have been impressed by her knowledge of hide preparation techniques that could improve their winter clothing. She might have been fascinated by his bone needle technology and its potential applications. Or maybe the attraction was more personal from the beginning. Despite their different ancestry, both were recognizably human. They shared the same basic emotional needs for companionship, security, and affection that characterize all human relationships. But there would have been enormous obstacles to overcome. They spoke different languages that had been diverging for hundreds of thousands of years. Their cultural practices, religious beliefs, and social customs would have been radically different. Even their physical appearances would have marked them as members of different human groups. Yet somehow, these barriers were overcome. The genetic evidence is clear. Denny's parents formed a relationship intimate enough to produce offspring. Her precisely balanced 50-50 genetic heritage confirms that this was a union between individuals from genuinely different human species. But as discussed earlier, was this relationship consensual and loving, or was it the result of political calculation, social pressure, or even force? The answer to this question has profound implications for how we understand ancient human societies and the nature of early intergroup relationships. The union between Denny's parents cannot be understood outside the broader context of survival in Ice Age Siberia. This was one of the most challenging environments humans had ever attempted to inhabit, where a single mistake could mean death for entire families. In such circumstances, every alliance mattered. Every relationship was potentially crucial for group survival. The decision to accept strangers into the community or to form intimate bonds with members of different human groups would have been made with careful consideration of the potential benefits and risks. From the Denisovan perspective, allowing Neanderthal refugees to remain at the cave brought both opportunities and dangers. The newcomers possessed valuable knowledge and skills that could benefit the entire community. But they also represented additional mouths to feed during the harsh winter months when food was scarce. The Denisovans might have calculated that intermarriage with the Neanderthal group could cement their alliance while also introducing beneficial genetic diversity into their population. Ancient human communities were generally small and isolated, making them vulnerable to the genetic problems that arise from inbreeding. From the Neanderthal perspective, forming close relationships with the established Denisovan community was probably essential for survival. They were strangers in an unfamiliar land, dependent on local knowledge for finding food, avoiding predators, and preparing for seasonal changes. A marriage alliance between a Neanderthal woman and a prominent Denisovan male could have provided security for the entire refugee band. It would have demonstrated their peaceful intentions while creating kinship bonds that could protect them from potential conflicts. But there's also a darker possibility that cannot be ignored. The relationship between Denny's parents might have been the result of conquest rather than cooperation. Archaeological evidence from other sites suggests that interactions between different human groups were not always peaceful. There are hints of violence, territorial disputes, and competition for limited resources. If one group had military advantages over the other, they might have imposed their will through force. Could Denny's father have been a captive taken during a Neanderthal conquest of the cave? Or might her mother have been claimed as a prize by victorious Denisovan warriors? The genetic evidence cannot answer these questions directly. A 50-50 genetic balance could result from either consensual mating between willing partners or forced reproduction between captor and captive. But there are clues that suggest the relationship was more complex than simple conquest. Denny's successful birth and survival to age 13 suggests that she was a valued member of the community, rather than the unwanted child of a forced union. Her hybrid genetic heritage would have given her unique advantages, the best traits of both lineages combined in a single individual. Moreover, the existence of other evidence for Neanderthal-Denisovan interbreeding suggests that such relationships were not isolated incidents, but part of a broader pattern of genetic exchange between the two populations. This implies that the relationship between these groups was characterized more by cooperation and integration than by conflict and domination. But perhaps the most intriguing clue comes from the broader genetic analysis of both Neanderthal and Denisovan populations. When scientists looked deeper into Denny's genetic heritage, they uncovered evidence of a hidden history that was far more complex than anyone had imagined. Her Denisovan father carried genetic material that told its own remarkable story. His DNA revealed evidence of Neanderthal ancestry dating back more than 300 generations before his own birth. This meant that interbreeding between Neanderthals and Denisovans hadn't been a one-time occurrence. It had been happening for thousands of years. But how was this possible? If Neanderthals lived primarily in Europe and Western Asia, while Denisovans inhabited eastern territories, how could there have been sufficient contact for regular genetic exchange? The answer suggests a pattern of migration and interaction that challenges everything scientists thought they knew about ancient human geography. Rather than living in isolation, these human populations were apparently engaging in long-distance movements that brought them into contact across vast distances. Climate fluctuations during the Ice Age created corridors of habitable land that shifted over time, sometimes bringing together populations that were usually separated by thousands of miles. During warmer periods, forests would expand eastward into Central Asia, creating migration routes that Neanderthal populations could follow deep into traditional Denisovan territory. During colder periods, the expansion of grasslands might have allowed Denisovan groups to move westward into regions usually dominated by Neanderthals. These climate-driven migrations would have created periodic opportunities for contact between the two populations, opportunities that were apparently taken advantage of for genetic and cultural exchange. But the story gets even more complex. Analysis of Denisovan DNA revealed that roughly 4% of their genome came from an even more ancient and mysterious human lineage, one that had split from the rest of the human family tree over 1 million years ago. Who were these ghost humans? When did they live? How did their genes end up in Denisovan populations? And what happened to them? The existence of this unknown human species suggests that the ancient world was far more crowded with different human types than scientists had ever suspected. Rather than the simple three-way split between Neanderthals, Denisovans, and modern humans that appears in most textbooks, the reality was apparently a complex web of relationships involving multiple human lineages, some of which have left no fossil evidence of their existence. This raises disturbing questions about what else might be missing from the human evolutionary record. How many other human species lived and died without leaving any trace except for fragments of DNA preserved in the genomes of their hybrid descendants? And if the ancient world was populated by multiple human species that were regularly interbreeding with each other, what does this say about the nature of human evolution itself? Traditional evolutionary theory suggests that species are discrete entities that rarely produce fertile offspring when they interbreed. But the evidence from Denny and other ancient DNA studies suggests that human evolution followed different rules entirely. Rather than diverging into separate species that could no longer interbreed, human populations apparently maintained genetic compatibility across vast evolutionary distances. Lineages that had been separated for hundreds of thousands of years could still produce healthy, fertile offspring when they encountered each other. This suggests that human evolution was characterized not by branching divergence, but by a complex pattern of separation and reconnection that created a web of genetic exchange spanning continents and millennia. But if this is true, then what happened to all these different human populations? Why are we left today with only a single human species when the ancient world was apparently teeming with human diversity? Perhaps the most haunting question raised by Denny's discovery is what happened to her extended family. The Neanderthals, who had survived multiple ice ages and thrived across Europe and Western Asia for over 300,000 years, vanished from the archaeological record around 40,000 years ago. The Denisovans persisted somewhat longer, with evidence of their presence until at least 50,000 years ago, but they too eventually disappeared as distinct populations. What caused this great disappearance of human diversity? Why did populations that had successfully adapted to some of Earth's most challenging environments suddenly go extinct? The traditional explanation has been competition. Modern humans, the theory goes, had some advantage: superior intelligence, better technology, more efficient hunting strategies, that allowed them to outcompete and eventually replace the archaic human populations they encountered. But Denny's existence tells a different story. Her genetic heritage proves that these different human groups were not locked in mortal combat for survival. They were capable of peaceful coexistence, cooperation, and even intimate relationships that produced successful offspring. If modern humans encountered Neanderthals and Denisovans and found them similar enough to mate with and learn from, why didn't these populations survive as distinct groups? One possibility is that the extinction was not really an extinction at all, but an absorption. Rather than being eliminated by modern humans, Neanderthals and Denisovans might have been gradually absorbed into the expanding modern human population through interbreeding. This would explain why genetic traces of these populations persist in modern human DNA, even though they are no longer present as distinct groups. The Neanderthals and Denisovans didn't disappear, they became part of us. But this explanation raises its own troubling questions. If absorption rather than extinction was the primary mechanism, it suggests that the disappearance of these populations involved large-scale interbreeding between modern humans and archaic populations. Was this voluntary integration between willing partners, or did it involve systematic physical coercion and cultural domination by expanding modern human populations? The genetic evidence suggests that most interbreeding between modern humans and archaic populations involved modern human males and archaic females. This pattern could indicate voluntary relationships between explorers and local populations, but it could also suggest systematic capture and exploitation of women from conquered groups. Without written records or detailed archaeological evidence, it's impossible to know which interpretation is correct. But the implications are profound for how we understand both ancient history and modern human origins. The period around 40,000 years ago saw dramatic environmental shifts that might have pushed already stressed populations past their breaking point. During this time, much of northern Eurasia was experiencing severe cold that made traditional hunting grounds uninhabitable. Modern humans, with different adaptive strategies, might have been better equipped to handle these environmental challenges. Their success might not have been due to superior competition with archaic populations, but to better adaptation to changing conditions. But perhaps the most disturbing possibility is that the disappearance involved direct conflict. Sites across Europe show signs of warfare, territorial displacement, and population collapse that coincide with the arrival of modern humans. Could the expansion of modern humans have involved systematic elimination of competing human populations? Did our ancestors engage in species-level warfare that resulted in the extinction of entire human lineages? The answer to this question has profound implications for how we understand human nature and the origins of modern civilization. Whatever the broader historical forces at play, Denny herself lived and died as a real individual caught between these different worlds. Her childhood would have been shaped by the unique cultural environment created by the merger of her parents' two traditions. From her mother's Neanderthal lineage, she would have inherited not just genetic traits but cultural knowledge that had been refined over hundreds of thousands of years. As mentioned earlier, this included sophisticated techniques for hide processing that were essential for creating warm, waterproof clothing. From her father's Denisovan heritage came knowledge of high-altitude survival techniques that were unique to that lineage. The ability to function efficiently in low-oxygen environments required not just genetic adaptations, but learned behaviors and survival strategies that had been developed over thousands of years. She would have learned to read the subtle environmental signs that indicated changing weather patterns in the mountains, to identify the plant foods that could provide essential nutrients during the brief growing season, and to navigate the challenging terrain that surrounded the cave. The bone needle technology that characterized Denisovan material culture would have been particularly important to her education. Young Denny would have spent countless hours learning to manipulate these tiny implements, developing the hand-eye coordination necessary to create the garments that made survival possible during the brutal Siberian winter. The cave environment itself would have been her entire universe during the long winter months when venturing outside was impossible. The three main galleries provided different spaces for various activities, and she would have learned the proper use of each area from both practical necessity and social convention. The main gallery, with its central fire hearth, served as the community's gathering place where meals were shared, stories were told, and the social bonds that held the group together were maintained and strengthened. Here, Denny would have listened to the oral traditions of both her parents' peoples, absorbing stories that preserved not just historical information, but the moral and ethical principles that guided behavior within the group. During the brief summer months when the cave's inhabitants could venture outside, Denny would have learned to navigate the challenging landscape that surrounded their home. The limestone cliffs that jutted from the hillside above the Anhui River provided both shelter and strategic advantages, offering elevated positions from which approaching animals or potential threats could be observed. As she grew older, Denny would have begun to develop her own specialized skills and interests. Perhaps she showed particular aptitude for tool-making, demonstrating the patience and precision necessary to create the complex implements required for survival in the harsh Siberian environment. Or maybe she possessed exceptional tracking abilities, displaying an intuitive understanding of animal behavior that made her valuable as a scout or hunter despite her youth. The robust skeletal structure and advanced cognitive abilities inherited from her Neanderthal mother would have provided her with the physical and mental tools necessary for mastering the complex survival skills required in such a challenging environment. This finding challenged fundamental assumptions about the relationship between human lineages and suggested that interbreeding between ancient populations was not just possible but actively beneficial for the health and survival of resulting offspring. As Denny reached adolescence, she would have begun to take on adult responsibilities within the community. The harsh realities of Ice Age life meant that childhood was necessarily brief, and young people were expected to contribute to the survival of the group as soon as they were physically and mentally capable. She might have participated in hunting expeditions during the summer months, using her inherited knowledge of both Neanderthal and Denisovan hunting strategies to help secure the resources necessary for winter survival. Her unique heritage would have made her a valuable member of any community. The combination of genetic adaptations from both lineages, enhanced by the cultural knowledge she had absorbed from representatives of both populations, would have equipped her with survival skills that few individuals of her time could have matched. But at the age of 13, her remarkable life came to an end. We do not know the specific circumstances that led to Denny's death, but the harsh realities of Pleistocene life meant that survival to adulthood was never guaranteed, even for someone as well equipped for survival as she appeared to be. Disease could strike without warning in communities where medical knowledge was limited to herbal remedies and basic wound care. Hunting accidents were common occurrences when survival depended on close encounters with massive, dangerous animals armed with nothing more than stone-tipped spears and wooden clubs. The brutal Siberian winter could claim lives even among those most experienced in Arctic survival. A sudden blizzard could trap individuals away from the safety of the cave, or a miscalculation in food storage could lead to starvation during the long months when hunting was impossible. Perhaps she fell victim to one of the many predators that shared the landscape around Denisova Cave: cave hyenas, cave lions, or the massive cave bears, that competed with humans for shelter in the limestone caverns. Or maybe her death was the result of violence between human groups. The period around 90,000 years ago was marked by dramatic environmental changes that would have created competition for limited resources. Conflicts between different human populations might have claimed young lives like Denny's. There's even a possibility that her hybrid nature made her a target. In some traditional societies, individuals who don't fit neatly into established categories can face discrimination or persecution. Could Denny have been rejected by one or both of the communities that had given rise to her parents? The discovery that her bone fragment showed evidence of having passed through the digestive system of a scavenger, most likely a hyena, suggests that after her death, her remains became part of the natural ecosystem of the cave region. This was not uncommon in the ancient world, where human remains were often scattered by scavengers before eventually being preserved in the sediments. What we do know is that her death would have been mourned by a community that had watched her grow from infancy into a young woman who embodied the best qualities of both her parental lineages. The grief felt by her parents would have been particularly profound. They had not only lost a beloved daughter, but the living symbol of their successful union between two distinct human populations. Her death marked the end of something unique in human history, a living bridge between two worlds that would never meet again in quite the same way.